All right, our work today is based on comparing and ordering integers, and that's exactly what our goal is. We want to be able to compare integers for less than and greater than, and if we have a bunch of them, we want to be able to put them in order like they would show up on the number line. And so we have to start off at the beginning. What are the integers? The integers are all the numbers that look like this, where we can include the negatives, 0, 1, 2, 3, 4. And so basically, they're all the things that you would use to count them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, keep going, as well as their opposites, all those negatives, -1, -2, -3, all the way on. We know that negative integers are everything from -1, -2, -3, -4, and so forth. Based on your earlier classes, I know that you've had experience working with them, and you understand that negatives are frequently used to illustrate loss. You know that, for instance, if you're going down into a hole, we can use going down to represent negative. Temperatures below 0 we would call negative temperatures. If you owe somebody money in the banking industry, those would be considered negatives. And positive integers are just the ones that you would count with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And please notice that 0 does not appear on that list because 0 is not positive, 0 is not negative, it's neutral. But 0 is one of the integers. Absolute value is defined as distance measured from 0. And we will have several examples of absolute value coming up. Opposites have the same number part, but different signs. For instance, +5 and -5 are opposites. A nice characteristic of opposites if you add opposites, they're always going to wipe each other out and create 0. +5 plus -5 is 0. In terms of a piece for notation, just for communicating, I also want to emphasize this note that we've got over on the left. There is a tendency for students to see something like this, and how do you read it? And I just had the same student say -m. That's not appropriate. Remember, we use letters, these variables, to represent numbers that we don't know. We don't know if this m is a positive number or a negative number. Imagine for a second that m were -4. This would be saying then, just plugging the m or the -4 in for the m, making that substitution. We don't want to say -4. That sounds really awkward and weird. -4. When we have this piece up here in the blue, instead of reading that -m, you should say opposite of m. Because we don't know that it's a negative number. If you say -m, it makes it sound like you know it's negative. And that might not be true, as this instance in the red would show us. What is the opposite of -4? Positive. And yet we still read it as -m. We made it sound like it's a negative number when in fact it would be a +4. Just as a way of trying to communicate more effectively, don't read these things as -k or negative x, or negative a. That's not how they read. You should read them as the opposite of k, the opposite of x, and the opposite of a. Okay, let's continue our notes. Use a number line to order the integers from least to greatest. Using the number line, of course, means graph on the number line. So let's just plot the point down for each one of them. 0 is right here. Negative 6, negative 2, positive 7, negative 9, positive 3. Make sure you follow along with what the directions ask. If the directions ask you to use a number line, you have to use a number line. When we order the integers, of course, we just have to put them in order from left to right. The number that's farthest left is the least. So looking at them, we would have negative 9, negative 6, negative 2, 0, 3, 7. Did I miss one? I missed the negative 8. Yep. I forgot to plot it earlier, so now I'm going to have to erase a bunch of this stuff because I missed the point that I plotted earlier. And I'm somewhat curious, did anyone catch the fact that I forgot to plot the negative 8 on it? If you catch me missing something where, I get brain dumb for a second and I just miss out on something, please don't let me get away with it. Stop me as soon as you see I do something wrong. Just because, welcome to being human. Everybody just does something silly. I didn't see the negative 8, so I made a mistake. Alright, let's consider this checkpoint then. Graphing on a number line. Take a moment, run through it. Alright, plotting our points. We had 2, negative 7, 6, 4, 0, negative 4, and negative 1. Writing them in order from least to greatest. Negative 7, negative 4, negative 1, 0, 2, 4, 6. And we're done. Right, so we know that opposites just have different signs. So what's the opposite of positive 3? And the opposite of negative 8 is positive 8. Visually, we see these things on the graph because we know positives and negatives have a direction to them. Right here, when we look at 3, that original number 3 is originally located 3 units to the left. We have 3 units to the left, and its opposite changes direction 3 units to the left. That's how we could quickly identify that it would be negative 3 if we needed to use the graph. I really don't expect anybody to sit down and actually use a graph to state the opposite of the number. I know that you're just going to change the sign, but it is important to have an understanding of why we call them opposites. We call them opposites because they're on opposite sides of a number line. When we have our negative 8, it is posted 8 units to the left of 0. So when we take the opposite direction to the right, taking that same length, it's another 8 units. And then we finish off at positive 8. I'm very aware that using a number line is not the most efficient way to quickly get the answer. We're going over the number line so that you can understand why we call them opposites. It's based on the direction. Absolute value is distance. Distance we don't think of as having direction. Distance then is always a positive because it's just the length. What's the absolute value of 7? Well, it just says make it positive.
-7?
It's already positive, so it's just 7. For -5, what's the absolute value of -5? Make it positive, so it's just 5. Well, why then? Why are we saying, we want to make sure that we understand not just how to get the answer quickly, but why is this the answer? We want to understand it, not just do it. In this instance, when we are looking at going to our question A, between 0 and 7, we can count out how many of these little spaces we have. When we actually count them out, we have 1, 2, 3, 4, 5, 6, 7 spaces, which is why they are 7 units apart. We're measuring and counting out the distance. That's what absolute value is. It's distance. We're noting then the distance between 7 and 0 is 7, so the absolute value is 7. We have the exact same thing happening in B. We're taking the distance between -5 and 0. How many of those spaces do we wind up having? 1, 2, 3, 4, 5. So it is a total of 5 units between them. We're recognizing the distance between -5 and 0 is 5 gaps, 5 tick marks, which tells us then the absolute value of -5 is positive 5. It is important for you to understand absolute value is distance from 0. All right, so quite quickly, what is the absolute value? What is the opposite? What's the absolute value of 9? Keep it positive. What is the opposite of 9?
-9.
What is the absolute value of -12? Make it positive. And the opposite of -12? Change its sign to +12. We're done.